Okay, guys, recording in progress. Welcome to our class today. Good morning, everybody. First, our class today, June 20th, 2022. Today we have two sessions. I sent in the announcement, in the last announcement in OWL, and I believe everybody received an email from OWL that also I attached the first session link, which we are in already, and the second class link. The second session, which will mainly be quiz 3 and quiz 4. So this is how we will proceed today. I'll continue today with arrays chapter to finalize it. Then we'll go to the polymorphism and inheritance, which would be the last handout in Java. Then if we have time, we will touch base with MATLAB. If not, we might take the second part, and we don't have a class on Wednesday to give you more time to solve the labs. Harnor, I sent two timing. The first one, the first session, it is 9 to 12, which we are in now. Then we'll have 1 hour break to study for the quizzes. Then we'll start 1 to 4, the second session. Clear now? Guys, do you have any questions? Anything regarding timing? I don't want anybody to be confused or miss the quiz or so. Okay. The good news is for you guys that I try to be fair as much as I can. So both the quizzes 3 and 4, there is no code writing a question. We'll leave it to the final. It's just multiple choices a question, both the quizzes. Happy or not? Because I received some email from students about writing code a question. So it would be multiple choice, mainly output. So you are welcome, everybody. I'm trying to help as much as I can. Welcome, Ryan. I'll just repeat very quick what we said. Today we have two sessions. The first session, which we are in now, which is 9 to 12. Then we'll have a break, 1 hour, like to revise or study for the quizzes. Then the beginning of second session, which is 1 to 4 p.m. We will have both the quizzes. Then after, if we have some curriculum to finalize, I believe it would be the MATLAB. So in Wednesday, we are done at that time with our course. So in Wednesday, we don't have a class, just the lab. So you will demo assignment 4 and 5, lab assignments, and be ready for the final. We will discuss this at the end of the second session. If you wanna, if you have a question, then we can have Wednesday class as a revision class to answer your question. To know that both the quizzes today, I received multiple questions about code writing questions. But to be fair and to release some pressure on you guys, I make it all multiple choice question. Mainly output and some basics question about what we cover. Sounds good? Questions about quiz 1 and 2. It's only 10 multiple choices, mainly output. But please make sure at the beginning of the second session that everybody camera is on. Okay? Done. Next Monday, we'll have our final exam. Our final exam next Monday in person, no exception. And guys, make sure that those who missed midterm, only one student, I think. If you miss the final, then you have to repeat the course. This is the university rule, and yeah, the final we'll talk about it at the end of the second session, Munib. It will be mixed format, same as midterm. Same as midterm. But it would be 3 hours exam. Any other question before we starting? We start our curriculum.
So there's still an in-person lab on Wednesday, right?
Yes, in-person lab.
Okay.
You will demo lab 4 and 5.
Yep.
If there needs some practical thing about MATLAB, then I can ask the TA to give you 1 or 2 example on MATLAB.
I see.
Yeah.
Okay, thank you.
Yeah.
And then thank you for the email as well.
You are welcome. Yeah, just because I was like unsure that some students, they might enter the other Zoom link that we used to go in. So I
Yeah.
want to make sure. Or some students, they are like missed. Oh, we'll start at 10, not at 9.
Yeah, and that was me. Thank you.
You are welcome. Any other question, guys? Don't hesitate. Feel free to ask. Okay, I'll pause recording now. Then we'll continue talk. Then we'll back to recording. Okay, guys, back recording in progress. So we'll continue where we stopped before. Can you see my screen?
Yeah.
Yes. Okay. 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 So we stopped last time here. So let's continue. Array of objects. We talked about last time the field, the length method, array of elements. Now we'll talk about array of objects. So I define a class. I define an array of instances of that class. So for example, since the string are objects, we know that arrays can contain objects. So since we did an array of string, so we can do array of objects. So for example, inventory system, inventory, new inventory 5. So I declared here an array of object of a class inventory item. How many item in that array? 5 items. We start at 0 and we stop at 5 minus 1. Here, this is what I mean to show you the UML. So here the class name is inventory item. Here we have 2 variables or 2 class members. They are private both. When we saw minus, that means private. Description, string, then units, which is integer. And here we have some public method, inventory item, which is the constructor, inventory item D string, inventory item D string, and integer unit. And we talk about this if we have multiple definition of constructor, how the program or the compiler will differentiate based on the type of parameter we are sending when we call those. Then we have the setters, set units, and getters, get description, and get units again. So each element need to be initialized. So how to initialize it? For I equals 0, I less than inventory length I plus plus inventory I equal new inventory item. So we have to connect, because this we told you that it will contain the address, right? How we will initiate the object? Here. And if you see the default for a string, it would be empty, null. And for integers or any numbers, it will be 0, as we discussed earlier. So this is how we declare an array of objects, and this is how we initialize them. Then the remaining, how to set, how to do, how to call, this is same as any other array members. Munib later will curve it. Later we'll talk about it. Okay. Multi-dimensional arrays. Munib, remind me if I forget to repeat what I said at the end of the second session, just remind me to repeat it. Okay. Okay, multi-dimensional arrays. Now, all of those, we deal with one-dimensional arrays. So it's array from 0 to 4 that contains object or string or items, whatever. But now what do we mean by multi-dimensional array? Multi-dimensional array that we divided to rows and columns. Two-dimensional array is an array of arrays. I have multiple one-dimensional array that combined in a tabular format. This is a 2-dimension. 3-dimension, it would be like XYZ in physics. I can thought of as having rows and columns. So one-dimensional array, one-dimensional array, one-dimensional array, one-dimensional. Then we combine them and we start calling the items as columns and the rows as one-dimensional arrays. So it would be indexed by two things, the row and the column. Before the one dimension, we declare it as I. We have one index for it. If you remember here, we have one index. Here now we will have another index. We'll see how. Like this one. Two-dimensional array of doubles, we call them scores. A new double scores 3 and 4. What does that mean? That we have 3 rows and 4 columns, which is similar that I define a one-dimensional array of 4 items and I have 3 of them. This is how we interpret this, that I have a one-dimension array of 4 items and I have 3 of those. I combine them together. Questions till here? So let's talk about the node. Declaring a two-dimensional array requires 2 sets of brackets and 2 size declarations. The first one is for the number of rows and the second one is for the number of columns. The 2 sets of brackets in the data type indicate that the score variable will reference a two-dimensional array. Notice that each size declared is enclosed in its own set of brackets. I cannot combine them as comma like C++. No, here I have to do double brackets, each one with its own index. The first one for the rows, which is the number of one-dimensional array, and the second one is for the columns. Questions till here before I move to the next slide. Clear? Okay. So how we can access two-dimensional arrays elements? When processing the data in a two-dimensional array, each element has 2 subscripts, one for the row and one for the column. This is how we can access an array element. Next slide will show us how we can do this. The score variable holds the address of 2D array, two-dimensional array of doubles. This is the address, sorry, which will point to the first item of the first row and the first column, which is normally indexed by 0, 0. Then we'll go by index. So this element is the index of it scores 0, 0. This one scores 0, 1, which is row column. 0, 2, first row, third column. First row, fourth column. Second row, always deduct 1 or minus 1. Second row, first item, second row, second item, second row, third item, and fourth item, and so on. Questions? Now, how to set values? Accessing one of the elements in a two-dimensional array requires the use of both subscript, which is the row and column. So when I'm saying scores 2 and 1 equal 95. So 2, third row, second column, always deduct 1, will be has the value of 95 because it's array of doubles. Clear? So here, program that process two-dimensional arrays can do so with nested loops. How, if you remember, in the single we use one loop for I equals 0, I less than length, I plus plus do this. But in two-dimensional array, I need a nested loop. Don't forget this. I need a nested loop. For integer row equals 0, row less than 3, row plus plus. For integer column equals 0, column less than 4, column plus plus, which is the number of rows, not the largest superscript, number of columns, not the largest subscript. So here, you remember when we talk about nested loop that we'll do 0, then we'll do this is all. So for the first row, we will do all the column, enter a score, keyboard.next double. So here, we will fill it row by row. Question about this? Questions about this? Good. To print the scores array, also we need a nested loop for integer row equals 0, row less than 3, row plus plus, integer column equals 0, then 4, less than 4, column plus plus, system.out print line scores row column. So here at the first round, we will print row 0, then we'll go from 0 to 3 in this one. So we'll print item 0, 0, 0, 1, 0, 2, 0, 3. Then we'll go to the outer loop, row become 1. Then we'll in the one we'll start from 0 in the second iteration of the outer loop. Then we'll go 1, 0, 1, 1, 1, 2, 1, 3. Then we'll back. So here row become 2, sorry. Then we'll start from 0, 2, 0, 2, 1, 2, 2, 2, 3. Then 3 now will go out of the loop. And here, for example, if we are initializing that a two-dimensional array, that requires the enclosing each row's initialization lets in its own set of braces. So here we have integer numbers. The first row would be 1, 2, 3. The second row would be 4, 5, 6. And the third row would be 7, 8, 9. So each row to initialize the value at one command, then we have to initialize them, each one also in its own bracket, which means row 0, row 1, row 2. This one would be row 0, item 0, row 0, item 1, row 0, item 2. Java automatically creates the array and fills its element with the initialization value. So if we print row 0, we'll find this, row 1 will find this, row 2 will find this. Declares any array with the 3 rows and the 3 columns. So we can do this. You can do in order like to make it more visual, more better format to your eyes to be more understandable. Then you can make it like this instead of being in one row. 1, 2, 3, 4, 5, 6, 7, 8, 9. First row, second row, third row. And if you see, it would be look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Questions? Questions? No questions. Okay. The length field. Okay, thank you, Ryan. The length field. Two-dimensional arrays are arrays of one-dimensional arrays, which is array of a one-dimensional array. How to consider it as one dimension? Each row is a one-dimension array. And the two-dimensional is arrays of one-dimensional array. The length field of the array gives the number of rows in the array. If we are dealing with two-dimension, it will give you the number of rows. Each row has a length constant, tells how many columns in that row. And each row, when we ask about the length of that row, it will give you how many elements in that row. Each row can give a different number of columns. So I don't define here how many items in each row or the index. I use it. So here I declare 3 rows. And in the first row, 4 elements, second row, 3 elements only there. Then there is 1 empty. And in the third row, we have 4 items. So for integers row, less than numbers dot length, which will give you how many rows. Okay. Then here, when we start with row 0, then we'll take the numbers of row 0 dot length, which will give us how many items we have here. Numbers row column. So number of rows, number of columns in this row. The array can have variable length row. So if we initialize it and we leave it empty, then I can have 6 items in the first row, 8 items in the second row, 2 items in the third row, and so on. So if we use this dot length, if we deal with row, it will give us how many rows in that two-dimensional array. If we are taking about certain row, the length, the dot length function will give us how many items in that row. Questions? Okay. Summing the element of a two-dimensional array. This is an example how to take the sum of items in two-dimensional array. So we have this one 1 2 3 4 5 6 7 8 9 10 11 12. Each row has 4 elements. We have 3 rows. Integer total equals 0. For integer row equals 0, row less than number dot length, which mean how many rows I have here. Then for column equals 0 to column less than number of row, which is 4. Column plus total, which is we start equal total plus number, the number here. So it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Then we'll print the total number of the array element summation. Clear? Or do you have any question about this examples, guys? No questions. Okay, sounds good. So here, if you see here, we use 2 4, then we print the total. Now here, what we will do, the same thing, total row, then we made the total inside the row. For integer, row, total numbers, row, column. So total of row number is total. So here we are doing the summation of each row individual. How we'll do that? Here we make the system output after the loop, and we put the total inside outside. So whatever added to the total will add the whole array element. Here we put the total inside the first loop, which because the task was to find the summation of each row. Then the system.out for the total is after each row. Clear? Questions about this? To make sure that you understand it, copy and paste it in your compiler and check the code, or it's inside the W3 spool in Java. Play with the code, move the total here, find, then you can play to find the sum of each column, not each row. You can play with those and do different style of output. Here you will understand by practicing. As I told you, this kind of courses like programming languages, how much you practice, how much you play with the code, how much you will understand. So here, what we will do, so find the numbers, we end the 4, total of column, here is column by column. We start here, as I told you, we'll find like this column, 1, 5, 6, plus 9, 15, 8, 18, 10, 21, 12, 24. We start the outer loop by columns. We initialize the total and then the row. Then the total of column, the number of column, like column 0 is like 15. Then the total of column 1 is 18, like this. So we just flip. If you need column by column, you start the first loop for columns and the second loop for rows. Questions?
I just have a quick question if you want to go back.
Yes.
So when you do the total of column and then plus column, it's printing like 0, 1, 2, but when it means 0, for us, it's the first column, right?
Yes.
Okay.
Normally with the index, we start with
Yeah.
0, 0.
0, yeah. Mm-hmm.
So if I have 4 columns and 3 rows, then I will deal with 0, 1, 2 for the rows and 0, 1, 3 for the columns. Always deduct 1.
Okay.
And start with 0.
Yeah, I got it. Thank you.
You are welcome. There is no difference between passing a single or two-dimensional array as an argument to a method, same as we pass the single or one-dimensional array or two-dimensional array. It is the same concept. The method must accept a two-dimensional array as a parameter. But we have, when we define the method, that as an argument of that method, it should receive a two-dimensional instead of one-dimensional array. For example, here we say ragged arrays. What do we mean by ragged arrays? When the rows of a two-dimensional array are different length, the array is known as ragged array. You can create a ragged array by creating two-dimensional array with a specific number of rows, but no columns. Like this one. I have 4 rows, but the number of columns is different. Then you create the individual rows. The first row is 3 elements, the second row is 4 elements, 5 elements, 6 elements. It's the same concept as this one here, when we define 4, 3, 4. But this was at the initialization and we leave it empty. But here, we fixed the number of rows, but we left the number of columns is unknown. Then we can initialize it as what we want. More than two-dimensional array, Java does not limit the number of dimensions, but that array may be. More than 3 dimensions is hard to visualize, but can be useful in some programming problems. But here it would be like a multiple two-dimensional array. The 3-dimensional array, it's a multiple two-dimensional array, one after each other. So here it would be row 0, column 0 here, and first array, which is page 0. Then this one, row 0, column 0, page 1. Row 0, column 0, page 2. It's like multiple two-dimensional array, one after each other. But also we start the index with page 0. Questions about three-dimensional array? Command line argument. Sometimes you can write a command line argument. How those are working? A Java program can receive argument from operating system command line like CMD. The main method has a header that looks like this: public static void main string args. The main method receives a string array as a parameter. The array that is passed into the args parameter comes from the operating system command line, which is the black screen. To run the example, Java command line, you can go to the Java command line. How does this work? arg0 is assigned how, arg1 is assigned does, args2 is assigned this, arg3 is assigned work. It is not required that the name of mains parameter array can be args. Clear? So if I write in the Java command line, how does this work? It would be like this. Because here I define it as a string, array of string. Special parameter type vararg. Vararg parameters are actually arrays. So public static integer sum, integer numbers, integer total accumulator, add all the values in the number array, integer value numbers, total plus equal or equal total plus value, return the total. And here's the example. Var args demo. So we have the main method here, integer results, result sum 10 and 20. Then we call the function sum. Here is the function sum, and it take integer numbers. The sum method take variable number of integer argument and return their sum. So total for integer value till the end of numbers that we receive. Here we send 2, so till the end of 2. So it will start at 0, 1. Then it will add the 2 values and return the total. Then we call the method with 4 arguments. We send 4. Then it will start from 0 to 3. Then it will add them and sum those 4 values. Then the third call, it will call these 6 elements. Then we'll print the results that we will receive. So here it will print 30. Here it will print 30, 30, 100. Then here 30, 30, 60, 100, 50, 210. Questions? So here we have the inventory description string here. This is what I mean, how your question in the final will looks like. I'll do this and open it and do like public inventory. I'll do this, I'll call this function, and I will give you this method. So you have to write the code or the required code. Is that clear? For the final exam?
That'd be very helpful. Thank you.
Yeah, so I'll give you this skeleton, just you have to write the code inside.
And then we would get the UML diagram too, right?
Sorry?
You would give us the UML diagram as well, right?
Yes, I'll give you
All
the
right.
skeleton and leave the space for you to write your code, and I'll give you this also.
All right, perfect. Thank you.
I hope this would help and will reduce the amount of missed marks in the midterm. In the
I
final.
hope so too.
Yeah. Okay, we reach to the end of this chapter. I'll pause recording to answer Munib. Okay, guys, recording in progress after the break. Welcome back, everybody. So now we'll start with our last handout in Java, which will talk more about inheritance and those things. Let me share my screen. Can you see my screen?
Yep.
Okay, thank you. So it is unit 9, inheritance and polymorphism. What do we mean by inheritance? What do we mean by inheritance? Inheritance, like, guys, yourself. Where do you get your genes, color, eye color, all of your specification? You inherit them from your father and mother, and your father and mother inherit them from your grandpa and grandma from both sides, and so on. This is what do we mean by inheritance. So we'll have a class, will perform like a parent, and we have a subclass, which is the child. And the child will inherit the properties and the specification of the father or the parent, a class. This is what we call inheritance. Classes that inherit from subclass. So sometimes one day also your son will inherit your genes. So you are a subclass of your parent. Your parent is a subclass from your grandfather and grandmother. So these things will continue so on. Then we'll talk about polymorphism, which is like a Greek word that means multiforms. Then we'll talk about abstract classes and abstract method. Then we'll talk about interfaces, and we will reach to the end of Introduction to Java course. So, class inheritance. What is inheritance? Generalization versus specialization. Real life, why we use inheritance? Because sometimes we have a general class and we need a specialized class. However, the specialized class has some properties or needs some properties from the generalized class. That's why we apply the inheritance concept in the object-oriented programming. Real life objects are typically specialized version of other more general object. For instance, the term person describe a very general type of people with a numerous characteristic. Student and instructors are people. They share the general characteristic of person. However, they have a special characteristic of their own. Instructor conduct lecture and prepare exam and so on. Student attend lecture and write exams. And then our course also lab assignments. So student and instructor are a specialized version of a person. Let's take another example. If we have a class called car or vehicle, vehicle could be anything. So we have some, this is the super class we call it, or the parent. Then we need some specialization. Then we can say car, lorry, or truck, motorbike, plane, airplane, all of them, they are a type of vehicle. But the airplane, the motorcycle, the car, the truck are specialized one of the general one, of the general version that we call it vehicle. Question still here. What do we mean by inheritance? Why we need them? Okay. So here, person, we call it the parent or the superclass, contains those attributes and methods that are shared by all persons. So in this one, we will identify or declare the generalized thing that is shared between any other subclasses. Then student and instructor, we call them are a child or a subclass of person class, but the student contains those attributes and methods that are specific to student. And here we will add the method and attributes that are specific for instructor. This that is a relationship. The relationship between superclass and an inherited class is called an is a relationship. A student is a person, an instructor is a person, a car is a vehicle. A specialized object has all of the characteristics of the general object plus additional characteristics that make it special. In object-oriented programming, inheritance is used to create an is-a relationship among classes. Questions still here about the concept of inheritance? No questions. Good. We can extend the capabilities of the class. Inheritance involves a superclass and a subclass. The superclass is the general class. The subclass is the specialized class. The subclass is based on or extended from the superclass. A superclass also called basic class, and the subclass also we can call it derived class. The relationship of classes can be though as of parent classes and child classes. So whatever you want to call, superclass and subclass, basic class and derived class, parent and child, all can work. The subclass inherits fields and method from the superclass without any of them being rewritten. We'll get them as it is. A new field and method may be added to the subclass. The Java keyword extends is used on the class header to define the subclass. Okay, just give me a second, guys. Recording back. Share my screen. Okay. So the Java keyword extend is used on the class header to define the subclass. So here I define a class, a subclass called final exam. I use extend keyword grade activity. So final exam is a subclass of grade activity. So we have a grade activity, score double, get the score, set the score, get the score, get the grade. So this is the getters and setters. So here we have public class grade activity. This is the parent. Public private double score, numeric score, public void set score double s score equal s, public double get score, return score, public character get grade, character letter grade, if score greater than 90, give it A, 80, give it B, 70, give it C, 60, give it D, then else F, return letter grade. So here, class demo, void main, double, keyboard will get the test score, grade, get the grade. Here we did a subclass, we call it final exam. This is how is the UML looks like. When you see an upper arrow, that means it's pointing to the superclass, to the parent, and this is the derived class. Okay, so graded activity contains those attributes and methods that are shared by all graded activities. This one contains those attributes and methods that are specific to the final exam. So graded activity or final exam is a graded activity. So inherits all non-private. Look, what we inherit, all non-private attribute and method from grade activity class. So here we have the score as double, which is a private. So we will inherit those, but I can access this within those. Okay, we'll talk about access specifiers just in the coming few slides. And here we have number of a question for the final exam, points each double, number of missed, Final exam question, integer and missed integer, get points each double, get number of missed as integer. So here, if you see private integer number of question, this final exam extends grade activity, this one. So how we know it's an inherited class? So we use extends. It's a new class which is inherited from graded activity superclass. Here we add that members of the final exam, then public final exam, integer question, integer missed. What we call this? Guys, what we call this? It's the same as a class name. What we call it?
Constructor.
Constructor, yes, thank you. So points each, set score, we do those things, but we use the get number missed, get points each, set score, we call the set score, which is from the parent. So final exam demo, this is the main function, how we will point, how we will do all of those things, how we'll get the score, how we'll get the grade, how we'll get the letter grade, all of those things. But you see here, this final exam is inherited from graded activity. This is the child, this is the parent, this is the superclass, this is the subclass, or we can call it derived class and superclass. Okay. Members of the superclass that are marked private are not inherited by the subclass. This is what I was talking about. Exist in memory when the object of the subclass is created, may only be accessed from the subclass by public method of the superclass. How we can access them? If we use those public thing that is inherited from the parent class can access this, because this class will contain those and the public thing from here. Okay. Members of the superclass that are marked public are inherited by subclass and may be directly accessed from the subclass. So if I access the public method, those public method can access the private members here. So inheritance, fields, and methods. When an instance of the subclass is created, a non-private method of the superclass are available through the subclass. The non-private, the public, or protected. When we say non-private, that means any other type, except the private. Final exam equal new final exam. Exam.set score, score, exam score. Non-private method and fields of the superclass are available in the subclass. Set score, new score. Constructor are not inherited. When a subclass is instantiated, the superclass default constructor is executed first. So when we instantiate a subclass, the superclass default constructor is executed first. See next slide. So here I have a class superclass 1, the constructor superclass 1 system. This is the superclass constructor. This is how you can play with the code to understand what's happening, which will happen first. Then subclass 1 extends superclass 1, private subclass 1. This is the constructor of subclass system. This is the subclass constructor. Here, but subclass object, we defined one of the derived class. What will happen? The constructor of superclass will execute first, then the constructor of subclass will execute second. You see here the result. This is the superclass constructor. This is the subclass constructor. So if I ask you about output, make sure that you are aware of this. Questions? Questions, guys? Okay. The super keyword refers to an object's superclass. The superclass constructor can be explicitly called from a subclass by using the super keyword. How? We can see here. Superclass 1 or superclass 2, superclass 2 constructor. This is the superclass no arg constructor. Superclass 2, the other constructor has an argument. So subclass 2 extends superclass 2, then we call it super 10. Which constructor? Super 10. So which constructor will be executed? The one with argument. So it will print the following argument was passed to superclass constructor plus the argument that we send, which is the 10. So the following argument was passed to the superclass constructor number 10. Then this is the subclass constructor. Then we do this. So when we use the keyword super, if we don't send argument, this would be executed. If we send argument, the second constructor would be. If there is also another constructor that has 2 arguments, then, and we send 2 arguments, then the third constructor would be executed first. Questions?
I have a question.
Yeah, go ahead.
So only the constructor with an argument is going to be printed, not the one without the argument, right?
Because we call the one we use the super with argument here.
So the other one is ignored.
If we send it without the 10, then this one would be executed.
Okay.
Also, if we don't call the constructor, then the default constructor would be executed. So try it. This is Omar, right?
Yes.
Yeah. So Omar, try it at your compiler. Send this one. Don't use super. Send it without argument and see the difference.
Okay.
Then define another constructor with 2, like integer, integer. Okay. And send 2 arguments and write like this one with 2 arguments. And see how it's going. Play with the code, you will understand how it's happening. But the only thing, if there is no constructor, the default constructor would be executed first. Even if I don't call it, just when I initiate the object of subclass, the constructor of superclass will be executed first. But if I use to call the superclass constructor, then I will use the super word. If I send that, if there are multiple versions of the constructor, however I call without argument, with 1 or 2, depending on how many declaration of the constructor here. No arg, 1 arg, 2 arg, different type, float or integer or double, even with 1 arg, each one will be called first before the subclass constructor. Clear?
Yes.
Okay. If a parameterized constructor is defined in the superclass must provide a no argument constructor. If we have inheritance and we have a parameterized one, then I have to declare a no argument constructor. Or a subclass must provide a constructor and it must call a superclass constructor. Then I have to make in the subclass, if I don't want to make the no arg constructor, then to be the default constructor, then I have to initiate a constructor here for subclass and call the super one with argument. If I don't want to do, not to do this one with no arg. Clear what I'm saying? Yes, no?
Yes.
Okay. Any other question from other students? Clear. Okay, Ryan, thank you. So calls to a superclass constructor must be the first Java statement in the subclass constructor. If I have argumented superclass constructor, okay? Overriding superclass method. What do you mean by overriding? A subclass may have method with the same signature as a superclass method. The subclass method overrides the superclass method. If I have a method with the same signature and same name, what do you mean by same signature? Same argument, same structure, with the same name. In the subclass, it will replace the one in the superclass, and we call it method overriding. For example, I have a graded activity. I define a score, set a score, get a grade, and we have this one in the superclass. Then I have curved activity, extend the graded activity. Then I have double row score, percentage, curved activity, at override, public void, set score double S. Then here, the set score here, override the set score here of the superclass. Also, get row score, we have here get row score, we don't have. Yeah, get percentage, we don't have here get percentage. So only the get score, I overrid it with a new one. Super.set score row score times percentage. So this method override this method. Is that clear?
Can you go into a little more depth of the override?
Override, what do you mean by override? A subclass may have a method with the same signature as superclass method.
Mhm.
Here, we have set score, it's public, double, set score, return score.
Mhm.
Okay?
Yep.
We have here public void set score, double S, row score equal S. So we have the same
Oh.
signature as the same here. So the one in the subclass
Over. Okay. I see.
will
Now, thank you.
override the original one.
Okay. Thank you.
You are welcome. Any other questions, guys? So the set score method override the superclass set score method. This version accepts the unadjusted score as an argument. That score is multiplied by the curve percentage, and the result is sent to an argument to the superclass set score method. So here we add the percentage, then we send it here. Because this one will just return the score it's received. But here I need the curved score. Same as I told you what will happen to the midterm as a curve. So here he used to add a percentage. Or we can say like it's equal row score plus 5, as we said, or plus 4. So why we override? In order to send the new grade instead of getting just the old grade from here. Is that clear why we use override? So here is the continuation of the program and how we will call it. Curved exam get row score, curved exam dot get score, curved exam dot get grade. Then here we'll take it as override. So you see here, overriding superclass. This is, if I bring you the UML class like this one, how to make sure that you know that there's an override here. So set scores as double void. Set score as double void, which means if you have the same name, then this method will override this method. Clear? So if you find a thing that is available with the same name in the superclass and in the subclass, the one in the subclass is override the one in superclass. Questions? Recall that a method signature consists of the method name, the data type method's parameter in order that they appear. A subclass method that override a superclass must have the same signature as the superclass method. And if you remember, when we talk about the signature, a few handouts ago, we said what is determine the signature, which is the method name, the data type of the method parameter. So those are the signature. The return type is not important. And if you see here, to prove what we are saying, here we make it void, but here it is double. So if you remember, if you go back few handout, the signature consists of the method name and the data types method parameters in order to that they appear. So here we have S double and we have here S double. Okay, and the same name and same parameter data type. But the return type is not important. Here we make it void in the override one, and here we make it double. A subclass method that overrides the superclass method must have the same signature as the superclass method. An object of the subclass invokes the subclass's version of the method, not the superclass's version. The @override annotation should be used just before the subclass method declaration. So we have to add @override here to tell it use this version instead of this version. This causes the compiler to display a error message if the method fails to correctly override the method and in the superclass. Why we use this one? If there is an error here, this statement will show me the error. Okay.
So the @override statement, so we have to put it because it's going to show us an error message if it doesn't actually override it.
Yes. This causes the compiler to display an error message, an error. It's not it's typos. An error message if the method fails to correctly override the method in the superclass. Clear? A subclass method can call the overridden superclass method via super keyword. So a subclass method can call the overridden superclass. So we can call the old version by put the keyword super. Super.setScore raw score times percentage. Okay. There is a distinction between overloading a method and overriding a method. What is the difference? Overloading is when the method has the same name as one or more other methods, but with different signature, which means different arguments. This we call it overload. Override, that we are replaced. When a method overrides another method, however, they both have the same signature. So in this one, we have when it's the same name but different arguments, same as in the constructor, where it was here. So superclass, but different signature, different operator. Here we call it overloading, constructor overloading or method overloading. But here, if it has the same signature, then it will called overriding. Okay. A method overrides another method, however, they both have the same signature. Overloading, different signature. Questions? Both overloading and overriding can take place in an inheritance relationship. Overriding can only take place in an inheritance relationship, but overloading, we can do it without inheritance. And you see, we did the constructor overloading before we touch base with the inheritance topic. In the previous handouts, we used the constructor overloading. So let's see this example. We have superclass 3, show value integer arg, system integer argument was arg, show value string arg. Here we take integer, here we take. This is overloading. Public show value integer arg. This method overrides one of the superclass. You see here, we don't use the overrid. So if there is an error, the compiler will not show it. Just give me a sec. There it seems. Shivali. She's joining the older class. I don't know. If you know her, please send her a message to join this Zoom link. Okay. So this method overloads the superclass. So show value double arg. So it's different in the signature. So this one overload it. But here show value, this overrid this version. So here subclass 3, my object in new subclass 3, I defined something from subclass 3, which is extended from superclass 3. Okay, then we define the object, then we show value and we send it 10, and show value we send 1.2, show value and we send hello. What will happen with 10? Subclass integer argument was 10. We send 1.2. Subclass the double argument was 1.2. Hello, do we have a string here? No. Then we'll go to the superclass, which is a kind of overloading. Then it will be superclass. The string argument was hello. Is that clear?
Yes.
Any other question? Okay, just I'll pause here a bit for one. Resume. Okay, recording back. I'll share my screen. Then back to our presentation. So you see my screen, yes? Hello, guys, do you hear me?
Yes.
Yes, thank you. Thank you, Ryan. Thank you, Omar. Okay, so preventing a method from being overridden. So if I don't want this method to be overridden, then I have to use final modifier will prevent the overriding of a superclass method in a subclass. Public final void message. If a subclass attempt to override a final method, the compiler generates an error. This ensures that a particular superclass method is used by a subclass rather than a modified version of it. If I don't want a modified version of this method and the only one to be used, the one in the superclass, then I have to use the word final. Okay. Protected class members. We talk about the private, that they are not inherited. Public, they are inherited. Let's see how we deal with the protected members of the class. May be accessed by a method in the subclass. So the subclass can access a protected members in the superclass by method in the same package of the class. So it could be accessed by the method in subclass. If I defined in the superclass protected members, concentrate here. If I use a method or an data variable item member of the class as a protected, if I defined it as a protected, so I can access it by a method in the subclass, by a method in the same package of the class. For example, the class package string. Can I access protected members? Yes. Java provide a third access specification. We call it protected. A protected members access is somewhere between private and public. Okay. Public, I can access it from anywhere. Protected can be accessed in the subclass, in the package, and we will see now with examples. Using a protected instead of a private makes some tasks easier. However, any class that is derived from the class or is in the same package has unrestricted access to the protected members. It is always better to make all fields private and then provide public method for accessing those fields. If no access specifier for a class member is provided, the class member is giving package access by default. If we don't define it, so it's given a package access by default. Any method in the same package may access the member. So if I don't write public, protected, private, then within the same package, that class member could be accessed within the package. So here are some tables that summarize the thing. Access modifier, default, no modifier. Accessible to subclass inside the same package, yes. Accessible to all other classes inside the same package, yes. Public, the same. Protected, yes. Private, no. So here, outside the package, outside. Here inside the package, here outside the package. Default, is it access? No, outside the package. Public, yes. Protected, if there is a subclass from outside the package that inherit a class with this package, even protected, we can access it. Accessible to all other classes outside the package, no. Only the public. And the protected within the package, not outside the package. All others, no. Is that clear or need more clarifications? Questions? Questions? Clear. Okay, Amr, thank you. Thank you, Ryan. So, chains of inheritance. As I told you at the beginning when I was explaining that your son will inherit some of your properties or genes. You got something from your father get it from your grandfather. When I mean father, that means both father and mother. Then your grandfather get it from your grandfather, and so on. This is, we call it inheritance chain. Classes that inherit from subclasses. So till the moment we talk about one level, superclass and derived class. What if the derived class has also another more specialized class? Object, graded activity, pass-fail activity, pass-fail exam. So we here have the object as a superclass, then as a subclass graded activity, but we inherit a subclass in the pass-fail activity, then pass-fail exam also is inherited from pass-fail, which is inherited from. So what do we mean? Pass-fail exam is a pass-fail activity, which is a graded activity, and this is a or an object. So graded activity, the same as we took before. Then pass-fail activity, extend the graded activity, same as this one. And it has a private double, min passing score, minimum passing score, pass-fail activity double, minimum passing score. Then override the character pass and fail instead of A, B, C, D, F. So we override the get to grade. Then we have pass-fail exam, extend pass-fail activity. Then we have pass-fail exam. Then we define it, get points each for each question, number of missed questions. Chains of inheritance, classes often are depicted graphically in a class hierarchy. A class hierarchy shows the inheritance relationship between the classes, graded activity, final exam, pass-fail activity, and pass-fail exam. So pass-fail activity and final exam, they are both subclass from graded activity, and the pass-fail exam is a subclass from pass-fail activity only. Clear or need more clarifications, guys? Okay. Polymorphism. A reference variable can reference instances of a class that are derived from the variable's class. Polymorphism means many forms. Remember it as this word, many forms. So a reference variable can reference instances of classes that are derived from the variable's class. So we have a graded activity, we define exam. We can use the exam variable to reference a graded activity object. Exam is a new graded activity from the superclass. The graded activity class is used as the superclass for final exam. An object of the final exam is a graded activity object. So new final exam 50 and 7. So a graded activity variable can be used to reference a final exam object. Graded activity, new final exam. So here we can use a graded activity to have a new final exam object, which is another form of a graded activity which took the properties of the final exam object. This statement creates a final exam object and store the object's address in the exam variable. This is an example of the polymorphism. So we have exam, which is a new graded activity. We use the final exam to connect the object created to the graded activity as a final exam. This example called of polymorphism. So I have now two forms, exam and final exam, which are derived from the graded activity. This means many forms. To give you an easier example, if I'm doing a system that use multiple languages, two languages, for example, English and French, I can use the same object to show the French text and the English text by doing the same thing, which means I use the same code to have multiple forms or many forms, one in English and one in French. Just in the new one, I change the English text to French text. Clear what do you mean by polymorphism? Those who are bilingual or trilingual, that they can talk different languages, you can use the same code. You can define the new object from the same code to represent different languages. Then you can add a button in your system like English, Chinese, English, Arabic, English, French, English, Spanish, English, Italian, English, Hindi, whatever the language is. This is an example of polymorphism. What does polymorphism mean? Many forms. Questions? The term polymorphism means the ability to take many forms. This is what I was talking about, which means that we are giving the object or the instances of the classes to have many forms. In Java, a reference variable is polymorphic because it can reference object of types different from its own, as long as those types are subclasses of its type. So I have a superclass, I define a new case, we call it exam, and we connect it with the subclass format, which is different than the superclass format. However, it's still exam considered as a graded activity instance. So we have for the graded activity multiple forms of its instances. Clear? Not? Yes, no, guys. Okay, sounds good. So as we said, as a graded activity, we have an instance, we call it exam. However, we define it from one of subclasses of graded activity as final exam. Other legal polymorphic references. From graded activity exam, a new final exam. From graded activity, we can a new pass and fail activity. From graded activity, we can call pass fail exam. And this is from the chain of inheritance, and we all refer to a superclass type. The graded activity class has three methods: set score, get score, and get grade. A graded activity variable, here we call it a variable of a graded activity, can be used to call only those three methods. However, even they are final or pass and fail, so we can call these three methods that are available in the graded activity. So get points of each, it's not available in the graded activity function. That's why it will give an error here. Get a grade, get a score, they are part of a graded activity, so they will work. However, this one will give us an error because it's not part of the superclass. So any variable from superclass that will use a subclass structure, it will only can contain the original thing that contains in the graded activity. Clear? Now, polymorphism and dynamic binding. What do you mean by this? If the object of a subclass has overridden a method in the superclass, then if the reference variable make a call to that method, the subclass's version of the method will be run. So we said here that we will use the superclass methods. But if we override a method of superclass in the subclass that we define the variable from, then the subclass's method, the one will be executed. So graded activity exam, new pass and fail activity, exam.get set score 70, system.output exam.get grade. Java perform dynamic binding or late binding when a variable contains a polymorphic reference. The Java virtual machine, JVM, determines a runtime which method to call. If it's override, it will call the new version of the overridden method, depending on the type of the object that the variable reference is used. Clear? Okay. Polymorphism, it is the object type rather than the reference type that determine which method is called. Example, see next slide, you cannot assign a superclass object to a subclass reference variable. We can do a superclass to a subclass. But can we do a subclass to superclass? No, absolutely no. So we have polymorphic, void main string, graded activity, test a new graded activity. Then a new graded activity, we make them as array. Then the second test, test new pass-fail exam. So we define a variable from the subclass of a graded activity, then a new final exam, then we will run them. So we'll take score 95, grade A, because we use the graded activity method. Then in the second one, pass and fail. So we override the original one. Then when we use the final exam, then we back to the original one, because final exam doesn't have a grade activity different than the original one. So it's back to B. Clear or not? You need more explanation for this program? I can go ahead. If it's clear, we can continue. Clear? Okay, Omar, thank you. Abstract data type. How much the timing now? Is it? It's 11:13. So do you need a quick break or shall we continue? Guys, a break or not? Break, please. A quick break, please, would be okay. Okay. So stop share. Let's back at 11:25. Sounds good? 10 minutes break. Sounds good? Okay. See you then. I will pause recording and we'll back at 11:25. So share screen. This one. Okay. Abstract classes and abstract methods. So what do we mean by abstract class? An abstract class cannot be instantiated, but other classes are derived from it. Abstract class serve as a superclass for other classes. The abstract class represents the generic or abstract form of all the classes that are derived from it. A class becomes abstract when you place the abstract keyword in the class definition. So abstract is a keyword. Public abstract class, class name. What do we mean by abstract class? That a class that we cannot has an object or variables from it, cannot be instantiated. We just use it as a superclass only. Is that clear, guys? So an abstract method has no body and must be overridden in a subclass. So when I have an abstract class or abstract method, then it has no body, but in the superclass we said that there is a method called X. Then we has to override it in the subclasses. An abstract method is a method that appears in a superclass but expect to be overridden in the subclass. An abstract method has only a header and no body. So access specifier, abstract return type, method name, parameter list. For example, So the student class is an abstract class that holds general data about a student. A class is representing specific types of students should inherit from this class. So we have a student, we have name, ID number, and year admitted. The constructor accepts as argument the student name, ID number, and the year admitted. So student, we send the student number string, which is the student ID, and sorry, name, ID, and year. So name, ID, number, year. Public string to string. You remember this, return name plus name, ID number, and the year admitted. The get remaining hours method is abstract. It must be overridden in a super class. Okay, so public abstract integer get remaining hours. So here we have abstract class and we have abstract method. This one we have it as access specifier, the word abstract, then type, then get remaining hours. So here, computer science student, so extend the student. Constants for the math, computer science, general education hours required for graduation. So private final integer, math hour are 20, computer science are 40, general education hour are 60. Math hours, computer science hours, and general education hours. So we have private integer, math, CS, general, then computer science student string and string ID, string year, super. We call the constructor of the super class an ID and year. Public computer science student string, also we send it, and we send the integer math hour and the computer science hour and general. Super, we send it, set math hours as math, set computer science hour and education, general education hour, set math hour. These are parts of the same class. So get remaining hours, we said it should be overridden. So string to string, and here we override the get remaining hours. So integer required hours, remaining hours total. You see here, we have it as just abstract, and we override it here. So calculate the total required hours, which is math plus computer science plus general education. Remaining hours, required hours minus math and computer and general education. Our return remaining hours. How many hours are remain for this student to be graduated? This program demonstrates the computer science student. So we have here computer, we said new computer science, Jennifer Haynes, and this is here this is the ID and this is the year admitted. Store values, it has 12 math hour, 20 computer science hour, and 40 general education hour. Then computer science student, it will display name, ID, and year. And the major computer science math hours taken 12, computer science hours taken 20, general education hour, the remaining hours are 48 hours. Munib, could you please concentrate on what we are studying and leave those questions about your final till the end of the class? I told you at the end of the second session, I leave open area to answer all your questions. Can you please? Making your mind busy with those things are taking your concentration in what we are studying right now. This is for your benefit, believe me. So just concentrate on what we are taking. Okay. So abstract methods. Notice that keyword abstract appears in the header and that the header ends with a semicolon. Public abstract void set value. Any class that contains an abstract method is automatically abstract. If a subclass fails to override an abstract method, a compiler error will result. So if you don't override it, an error will happen. Abstract methods are used to ensure that a subclass implement the method. Why we do this abstract? That each subclass will apply the method on the way that is suitable for that subclass. Then interfaces. An interface is similar to an abstract class that has all abstract methods. It cannot be instantiated, and all of the methods listed in an interface must be written elsewhere, which means overridden. The purpose of an interface is to specify behavior for other classes. An interface looks similar to a class, except the keyword interface is used instead of the keyword class, and the method that are specified as an interface have no bodies, only headers that are terminated by a semicolon. Public interface name, methods, headers. This was called in C++ like a function prototype. The general format of interface definition is as the following. All methods specified by interface are public by default. A class can implement one or more interfaces. If a class implements an interface, it uses implements keyword in the class header. Public interface relatable Boolean equals grade activity G. We send the grade Boolean is greater is less than. So relatable interface. So if we have final exam, extend the grade activity, implements relatable. So here that it will use an interface called relatable. So we have number of question, point, number of missed, as same as we took before. Then we have the final exam 3 constructor. We send the number of questions and the number of missed questions. Then point each 100 divided by the number of a question. Numeric score is 100 minus missed point by each. Set score in numeric score. Then get points each and number of missed question. These are the getters. So here public Boolean equals status. If this dot get score equal G dot get score status equal true, else equal false. Boolean is greater, then that will do the same. If it's greater, if the mark are greater or less than of the number. So here public class relatable exam, public static void main. Then here we get the final exam, new final exam, we send 120 and 130. Display the exam score. Then if exam 1 dot equal exam 2, then the exam scores are equal. Exam 1 is the highest, exam 1 is the lowest. So here how we define interfaces. Okay, we use implement. Fields and interfaces. An interface can contain fields declaration like integer field 1, field 2. All fields in an interface are treated as final and static. So we cannot change them. Because they automatically become final, you must provide an initialization value. So we have to give initial value. In this interface, field 1 and field 2 are final static integer variable. Any class that implements this interface has access to these variables, because we said it's public by default. A class can be derived from only one superclass. Java allows a class to implement multiple interfaces. When a class implements multiple interfaces, it must provide the method specified by all of them. To specify multiple interface in a class definition, simply list the name of these interfaces. So public class, my class implements interface 1, 2, and 3. You need to list them. Interfaces in UML, grade activity, final exam, then we make it as dot. relatable, not as a solid line arrow. It will be a dotted line or dashed line with an arrow indicates implementation of an interface. Polymorphism with interface. Can we have the same interface with different forms? Java allows you to create reference variable of an interface type. An interface reference variable can reference any object that implements that interface regardless of its type. This is another example of polymorphism. So we have public interface retail item, public double rectangle. Then we said that the class compact disk implements retail item. So here we define the variables or the members, and here are the member functions or member methods. And this is the constructor. These are the getters. Also, this class, another DVD, also implement retail item. And polymorphic interface demo. Then here we can, from compact disk, CD, new compact disk, then DVD movie, new DVD movie, then we can print them. And here we have that we use the same interface in two different subclasses. This is another kind of polymorphism. In the example code, two retail item reference variable item 1 and item 2 are declared. Item 1 variable reference to a compact disk and item 2 to a DVD movie. When a class implements an interface relationship known as interface inheritance is established. A compact disk object is a retail item and a DVD object is a retail item interface. So any reference to an interface can point to any class that implement that interface. So a retail item, a new retail item, this will make an error. You cannot create an instance of interface. We can create an instance of a class that use that interface. When an interface variable reference an object, only the method declared in the interface are available. Explicit type casting is required to access other method of an object reference by interface reference. So here we finish the Java part of this course. Any questions? Any questions, guys? Okay, I'll stop recording right here. We are done with Java. Then we'll talk about the quizzes in a bit. Then we will